Okay, we'll start with this problem where what we need to do is to find the static friction force in the situation when we apply some force of the push to the block but the block doesn't move. Okay, so let me redraw this diagram once more. So we have the block, there is a force of the push, and there is the force of the static friction. Okay, I'm only drawing the forces in the x direction because this is what is relevant in this situation. And where is my x direction? Here we go. This is my x-axis. Remember that for the static friction force, we have the following equation, which is not very helpful in this situation, that the static friction force is less or equal than the coefficient of the static friction force times the normal force. But the static friction force can be less than this number, all right? So the maximum value of that, the maximum value of this friction force would be mu s times n, but this is not what we need to find. We need to find the static friction force. But what we know is that the block doesn't move. If the block doesn't move, then the force in the x direction is the acceleration in the x direction is 0. This means that the net force in the x direction is also 0. Okay, so what are the forces which contribute to the net force in the x direction? Well, there is a force of the push, okay, plus there is a contribution from the force of the static friction, since its direction is opposite to the direction of the x-axis. We will have to include the negative sign here. And now we can just solve this equation for the static friction force to obtain the following result, and then substituting what we know about the force of the push, we will get the final answer.